In this video, what we're going to do is solve equations with pronumerals on both sides. So they're equations, but we see pronumerals on both sides of our equal sign. So we want to be able to solve those types of equations because that's what happens sometimes in some problems. So we have a look at an example. Now this is all we really need to look to do is collect our terms when we work through a problem like this. So we want to usually get the numbers on one side and the pronumerals on the other. So it just depends on what we've got. Like in this one here, we want to probably aim to get our pronumerals on that side and our numbers on this side. It doesn't really matter which way we go, but we can go there either way. So the way we're going to do this, we're going to look at having an x there. We want to get the x on the other side. So we just want our x's on our left-hand side. So what we can do is, like we do with normal equations, we'll just subtract the pronumeral on that side. So that would give us 2x, and we'll have the subtraction 4 there. And that will just leave us with 4 on this side. So the x's have gone there because we subtracted from both sides. Remembering what we do to one side of an equation, we do to the other. Again, we get our numbers together. So we've solved problems like this before. So we'll add our 4 on both sides, because we know that 2x would have to be equal to 8, because 8 minus 4 is equal to 4. And then 2 times what number gives us 8? X would be equal to 4 there. Make sure we can check the work, so we'll check and go, well, 3 times the 4, because if x is equal to 4, minus 4, and if we solve that, that gives us 8 on that side. And on the other side, we'd have 4 plus 4, which also equals 8. So we know that x is equals 4 is a solution to that equation. So we check another one. This one's a little bit harder, but it's along the same lines. It's just got different numbers, a little bit larger numbers. But again, get your pronumerals on one side. So subtract 4x there, and that would give us 3x plus 4 equals 19. And again, what number plus 4 would equal 19? We get 3x. We subtract the 4 there, subtract the 4 there. That gives us 3x equals 15. X would be equal to 5. So 3 5s are 15, 7 5s are 35, plus 4 is 39. That works. So does it match up this side? 4 times 5 is 20, plus 19, 39 on both sides. So the last one here, we've got the larger value of x on this side and it's smaller. So the 5x is on this side, 3x on this side. So this time I'm just going to subtract the 3x. I'm going to keep it going that way. So I'm going to end up with 7 equals 2x plus 9. But that's okay. It's not a problem. We can have positives and negatives all around. And that won't really make a difference because we'll take the 9 away. And that's going to give us a negative. So that's going to give us minus 2 is equal to 2x. So that'll leave us with x being equal to minus 1. Again, go back and check, make sure it works. But that's how we start to solve equations with problems with equations on both sides. If we do get ones where we might have brackets or anything else, expand your brackets. If you've got fractions, you can still work with fractions like you did what we've done before. But it doesn't make much difference if there's pronumerals on each side. We just make sure we collect them on the one side.